Welcome back. Please be sure to check out the first video, which is linked in the card. So take this here and then do Control C and then Control V. We're going to add the code for the subtract button. So now with this button selected, right click on it, go and access its properties from the menu that shows up. Okay, so access the properties pane on the right side. Scroll up if you have to. Move this over. Now it says name, so we're going to change the name from button 1, which is what's given by default when you copy an object, and just change it to btn and then subtract. And then scroll down through the properties and then find the text property and then click there and then change that to subtract this way. And then go back into the interface, click back on the button, make sure it gets selected, and then just expand this a little bit so the word subtract fits. And with that in place, double click on the subtract button. Okay, bring up the code stub. Again, I'm just gonna basically copy this code from above where we did the add button code, but I'm gonna walk through it again and explain some additional details. So one more time. In order to avoid having code that crashes, you need to use the try parse method. Also some additional mathematical details. So 2 plus 5 is 5 plus 2 is equal to 7, right? That makes no difference. When you subtract, it does make a difference. So for example, 2 minus 5 is negative 3, but 5 minus 2 is positive 3. There's a difference in the outputs that you get. So we have to decide what we mean by subtraction. So for the sake of consistency, I'm going to take whatever's in that box, which is the second box, I'm going to subtract it from whatever is in the first box consistently. So in that case, I will say the following. If double that try parse again, so put your mouse over try parse, look, it returns a Boolean value, right? Which means you can use it with if to make a decision, okay? And then it says string as here, never mind the question mark, not relevant right now, okay? So if try parse and then needs a string, where do you get your string? You get it from the text property of the first box. You'll say txt first, and then dot, and then let's see, what else? Text, comma, and then it says out double results, so type out double, and then name your variable. Doesn't have to be called result, you can call it R1 for example, okay? So one more time, let me illustrate what this is doing. So like, as far as C# is concerned, this is what ends up essentially in the text property of a text box. Even if you type 2.5 without the double quotes, it's brought into the program with the double quotes by C#. So you need to basically make a numerical form out of that number. So how do you do that? Well, you do that by using try parse. In other words, when you type double that try parse, and in this position, this is a string object right there, so you could literally just type this right there. This is convertible to numerical form, and this part then out double, call it R. Then R would represent the value 25 without the double quotes, a numerical version of it of the double data type. Okay, that's why it has to be constructed this way. Obviously here, in a real program, you don't want to hard code values, right? They need to be read in. And then after that, and, so the logical and, double ampersand, punch down a line, and then repeat it. So double that try parse, and then txt second, like this, and then dot text, and then out double R2 this way. Punch down a line. So one more time, it's exactly the same logic. Try parse will now take the text from the second box, and if it can make a numerical value out of it, that numerical value will be stored in R2, in that double data type object, and at the same time, it also returns a Boolean that tells you whether the conversion is successful or not. That's why you can use it with if. So the try parse method is powerful because, again, let me stress, it does two things. It returns a Boolean telling you whether or not a conversion has been successful, and when it is successful, it returns the value from the conversion. And then from there, we can basically do what we did up here, which is this. LBL output, so LBL output dot text, and then plus equals, because we're appending, building up, and then dollar symbol, double quotes for string interpolation. Again, we want to output on individual lines, so /n for a new line, and then difference is. Now, let's be careful here. As I've said, you want to stress that, for example, well, the second taken away from the first, or the first minus the second. So here, instead of using the word difference, I'm going to be a bit more clear. I'm going to have R1 within the set of curly braces for string interpolation. So at runtime, it will be replaced with the actual value. Minus in brown, that means that's going to stay on the screen. R2 within the curly braces, so that will be again replaced at runtime with the actual value R2 represents. that's equal to, and then do the actual subtraction, R1 minus R2. So the second being taken away from the first, or if you like, the first diminished by the second, and so on. Okay, pull up a little bit. And the other possibility then, of course, is conversions don't work. Also here, make sure you terminate this with a matching parentheses at the end. So we'll say else, and then just output some kind of error message that says something has not worked. I will say lbl output dot text, again, plus equals, and then dollar symbol double quotes /n for a new line, and then input must be in numerical form. What we really mean when we say numerical form in this context is convertible to numerical form from string form. In other words, something like this, right? 25 or 50 or whatever, that can be converted to numerical form. That's really the code. So let's give it a try here. Okay, start with that debugging controller 5. Let the program get built and load into memory. All right, so we're going to subtract. So input, for example, 10 and then 2. You can just tab through, so hit the tab button like this, you see? And then hit subtract, and it tells you 10 minus 2 is 8. Let's try with some negative numbers. -2 minus 5. Subtract, and it tells you -2 minus a -5 is like -2 plus 5, which is +3. That is correct. That's the way it's supposed to be, see? Because we're subtracting. Then you get two negatives here. Let's also do this example. So do something like 10, yeah, and then 20. So this is like saying 10 minus 20 equals -10. That's also correct. Now do add. The sum is 30. If you like, you can change the sum part to be consistent with this one. So terminate this, go back over here. So instead of saying sum over here, let's just make it the same. So we'll say R1 individual value plus R2, for example, individual value. You want to display them and then do the addition in the last set of curly braces using string interpolation. So run this. Okay, start with that debugging controller 5. Okay, so look at the difference. So it's going to be 2 and 5. When you add them, you get 7. And 2 minus 5. When you subtract, you get -3. It's working correctly. See? Terminate. This is all of the code. Please check out the link in the card to the first video in the series. Please leave a like on this one.